Oke, halo guys. Selamat siang ya. Selamat datang juga buat hacker-hacker ini ke learning session yang ke berapa ini ya? Bentar. Ke 1, 2, 3, 4, 5. Kelima di Software Engineering Path ya. Sekarang udah 18 Januari dan memang udah tinggal dikit ya ini learning sessionnya. Udah hampir selesai. Eh, Hari ini kita kenalin, aku Andre dari Divisi Application di GDSC UGM. Aku di sini bakal jadi moderator kalian dan aku ingetin dulu buat kalian yang bisa tolong on cam dan pasang virtual background-nya kayak kemarin-kemarin ya. Dan langsung aja kita kenalan dengan speaker kita hari ini dan kebetulan speaker kita di learning session sebelumnya sama Kak Farel dari Remnode Software Engineering Kak Remnode. Oke, halo Kak, apa kabarnya?
Halo, baik. Nggak apa ya kalau pakai bahasa Inggris?
Oh, nggak apa-apa, nyantai aja.
Ya,
Oke, so langsung aja mungkin ya, waktu dan tempatnya aku langsung kasih ke Kak Farel. Semangat belajar, guys.
all right. Thank you for the introduction. Hi, everybody. Today I will be talking about working with APIs. I was here last week to talk a little bit about state management in Flutter. Just to sort of reintroduce myself, in case some of you weren't here last week. I'm currently a software engineer at Remnode, and previously I've had about 3.5 years of working as a software engineer. Plus, I'm also still an undergraduate student for computer science. Yeah, so let me just share my screen and I can begin the presentation. Oh, I think. Oh no, give me a sec. I think I need to rejoin the meeting, sorry.
Oke, ditunggu bentar ya, guys. Kak Farel kayaknya ada gangguan. Dia bakal rejoin meetingnya bentar lagi.
Let me try that again. Okay, so that's not great, but for whatever reason, I cannot share my screen because I'm on Linux and that this kind of thing happens. So instead, I will just share my presentation and we can all go through it together. There you go. Maybe someone from the team can help share that instead of me. But while they do that, I can just start going through it. So a couple of things similar to last week. I'm sort of just making a few assumptions on the kind of knowledge that you have beforehand or the kind of things that you're familiar with. One assumption is that you have a basic understanding of JavaScript. Thank you. You have a basic understanding of JavaScript or any sort of common programming language. You have your chosen language installed already in your machine or just a browser. You have Git installed on your machine, which which I think will be important later on because I made a few demo applications on GitHub. And if any of these things aren't true, please see the additional resources at the very bottom for any helpful links, or again, ask a question anytime in the chat, or I don't know, maybe just unmute yourself and just speak there. So let's start out. So I wanted to just give a brief introduction on what APIs are and what REST APIs are. So this definition, I think, is like somewhere from like from an IBM page. An API is like a set of rules that define how applications or devices can connect to and communicate with each other. That's kind of a super general definition, which is appropriate because APIs are super general. When you're talking about an API, you can refer to anything from like a web API, which we'll be talking mostly about here, or really just like a way to interact with a certain software library or just a piece of software. So certain specifications in JavaScript for certain things are sometimes called APIs. So like you have this API for I don't know, certain events in JavaScript or something, or maybe you have this API for interacting with this mobile package on iOS or something like that. But as I said before, today we'll be talking mostly about web APIs, which are basically APIs where you're talking about connecting to and communicating with a server somewhere, as opposed to a software library or anything like that. Of those web APIs, there are a number of different ways that these are typically structured. We have REST APIs, we have RPC, SOAP, and that one's kind of a bit older, and many different others, all of them kind of overlapping in what they do or how they look like. These others are kind of out of scope for this talk. I will mostly be talking about REST APIs. REST here is just a way to structure an API, and it's kind of like a standard format of structuring your API and like how you communicate with that API. REST itself stands for representational state transfer, but I mean, the actual specification gets kind of complicated, but I just wanted to sort of break it down and attempt to discuss like the fundamentals of it. Oh, and by the way, I'm going to try and discuss this as generally as possible. I think I was actually supposed to talk about working with APIs with Flutter specifically, but I think I'm going to try and explain it as general as possible, just because APIs or REST APIs are something that you can work with basically anything, as long as you can communicate via HTTP or whatever the API is using for its networking protocol. So that's pretty much any programming language. Although in the examples, I will be using JavaScript just because I had to pick one. And it seems like JavaScript is the easiest to work with when it talks about, well, when it deals with REST APIs, just because it already runs in the browser and things like that. So the basics of REST APIs. So with REST APIs, I guess there are sort of two main building blocks that you have. You have a request and you have a response. What I mean by request is the thing that you send to the API. And by the way, with the REST API, typically when we're talking about a REST API, it's just a series of URLs. We call them endpoints. And each sort of URL kind of refers to a specific resource, which I'll explain later. But for now, what you need to understand is a request is what you send to the API. And within this request, it's composed of things like headers, which is information about your request. You have your method, which is what you're communicating to the API server. That's the thing, you're communicating to the API server that you're trying to use a certain method, and I'll explain that later because that's kind of complicated. You have your payload or body, and this is the actual content of your request. So this is where the information in your request is stored. So if you're trying to work with an API where you can add things to a database, then your payload or body would probably be that thing, like whatever item you're trying to add to the database. as well as some other stuff. And like I said before, you have the URL or endpoints. That's where that's the place that you're requesting to. And then you have something called a response, which is kind of the opposite. So it's what you receive from the API. So after you send a request, you typically receive a response from the API server. And that also has headers. And it may or may not have a payload or a body, depending on the method that is like expected for it. And it has like a status code, which is basically just a code that summarizes that the server sent to summarize what happened. So I'll explain that later again. Like I mentioned previously, these things called methods. These are basically just sort of codes in order to tell the server what you're trying to do. And an API server typically accepts a whole bunch of these. There's a whole list of them. Probably the most commonly used ones are just get and post. So get is just a way of saying to the server that you're trying to retrieve some resource. So a popular public API is the IMDb API, like the movies database API. And typically in that API, you would be making get requests in order to get, let's say, details about a certain movie. And one of the characteristics of get requests is that it's mainly meant for retrieving data. It typically does not have a body, although I believe it's not forbidden in the specification. But you typically don't send a body, so all of the data is just encoded in the actual endpoint, and it's what's called idempotent. So basically, what that means is if you try to do multiple get requests, multiple get requests sequentially, like one after the other, then you don't expect it to sort of change anything on the server, and you sort of expect a predictable response, like you're not changing any state in the server, or at least that's what it's supposed to do. And then you have a post method, which instead of asking for, where previously a get method is for reading data, post can be really reading or writing data. This is where you expect to do things on the API server, and therefore it's not idempotent. So when you make multiple post requests one after the other, then you expect for things to change on the server and maybe for the state to change there. Now this is I'm explaining things in kind of like a vague term, but this will hopefully be more clear as I go through with like the examples. And then we have the status codes, as I said previously. Now some of these status codes you might be familiar with. Probably some of the most common ones are a 200. This is kind of the default status code when nothing went wrong. So when the API was found, like the URL was correct, when you were sending the correct headers and the correct data to the URL or to the endpoint rather, and everything turns okay, then it sends you a 200. Or the API server is supposed to send back a 200, which just means okay. When it's not found, so for example, when the endpoint doesn't exist, or when the resource that you're asking for doesn't exist, then it's just a 404. So a lot of you might be familiar with this. When you go to a website and you go to a route that's not expected, then you'll just get a 404. So that's what that means. And a 500 is also very common. This is kind of like a catch-all status code for, things went wrong in the server. This could just be an error that happened in the server, or it could be just referring to a general error if the server doesn't want to be more specific. Although there's like a very long list of status codes where it's very specific and it covers a lot of different scenarios. Then we have something called content types. These are basically things that you specify in your request headers. And although I believe they can also be sent in the response headers. And this is basically just a way to specify what the content of what the content of your body is. So this could be a lot of things. You could be sending all kinds of things, and the server wouldn't really know, any given server wouldn't really know how to handle it unless you specify the content type, or it's already expecting a certain kind of content type. So some common examples are just text HTML or form data. This is the content type that's sent when you submit something using an HTML form. And a very common one is application/JSON, which is basically when you're trying to send a request and say like a post request, and your post request body is JSON, then you would want to tell your API server that it is JSON so it can parse it correctly and handle it correctly. Next, I want to talk about public and private APIs. Like all APIs are primarily can be pretty easily separated between these two, and they do matter in how you deal with the API. So there are these public APIs, which basically means there's little to no authorization, meaning you don't need to send any sort of API token or have any sort of cookie or be logged in or anything like that. You just need to make a regular request, and it'll usually work just fine. However, these are often rate limited, meaning if you make too many requests within a certain period of time, then you just won't get any, or the server will respond with, too many requests or something like that. And then you have your private APIs. These are pretty much all of the majority of APIs that everybody uses, whether they know it or not. Say like the API that's called when you go to google.com or Twitter or YouTube. These are typically where authorization is required, where the API is usually expecting some kind of cookie or token, which usually comes from the logged in user. When you log in as a user, then you typically receive some sort of authentication token, and this is what's used to authorize the request to the API. Or sometimes there are APIs where you have to sign up first in order to get an API token, or perhaps you need to pay. So these are sometimes still rate limited, but most likely much less so than public APIs. And these might not be documented at all or intended for public use. So there are some private, quote, private APIs that are intended for public use. So if you go to like a list of public APIs on GitHub, some of those aren't totally public, meaning you do need to sign up and get an API token, or pay and get an API token. And I would basically call those private. And what I mean by might not be documented at all are the sort of APIs that underlie the majority of websites that people use. And as for ways to authorize your request, I mentioned a few before, but this can pretty much be anything. There are a lot of ways to implement authentication and authorization on web. So, but a couple basic ones are just like a cookie, which you use which you maybe send in a header to authorize your request, or maybe something like a JSON web token, which can be your API token. Although there's many different ways, and I do encourage you to look into all of them. So this is the beginning of working with APIs, is just interacting with the REST API. You can use anything. It's quote just HTTP, which is why I wanted to just not focus on a specific language. So here are a couple examples which you can hopefully just copy paste and run locally. So if you try and maybe the first, I don't know if everybody has Bash, because I know some people use Windows and I know the terminal works differently there. But if you just copy paste that and go to your terminal, then you will actually, let me see. Let me try it myself. And well, I don't know if you can copy paste that actually, because this shared document, or maybe, yeah, you can just type that in into your terminal. So this is using the Open Library API, which is kind of like an open version of Goodreads. It's just a big database of books and literature. So if you try and run any of these examples, as for the JavaScript one, you can just run it in your browser console. So if you go Control-Shift-I and just type this into your console, then I believe it should work. Kind of the same thing with Python. You can just run a REPL in your terminal, or maybe find I don't know, an online Python interpreter or something. And these should all pretty much print the same thing, which is that you get a big JSON body, which contains the number of books found, and it has this key called docs, which is just a bunch of search results for the author Pramudia Nandatur. And it tells you all the different books, and it shows you things like the opening line, or the publisher, or the date of publish, and a whole bunch of things. And this is basically, these three examples are basically how it works for every API. In this case, it's just making a GET request. So like by default, curl, I think, just makes a GET request. In the JavaScript one, we didn't specify a method, so it just makes a regular GET request. And in Python, we do request.get. And this is basically just how it's done for every API. We might need to send additional things for certain APIs, but for Open Library, they don't expect anything. It's a public API. And yeah, I mean, that's how you work with an API. When you interact with the REST API, that's pretty much all you need to do. Now I want to show you creating a REST API. So if everyone can just kind of go to that repository and follow the instructions, that would be great. It shouldn't take too much time. If you don't have Node or NPM or anything like that, don't worry about it. But if you do, it would be very good if you can do it. Oh, can the person sharing the screen click the repository, please? Thank you. And maybe just go to index.js. Yep, cool. Right. So this is an example of a very basic API server. All this is it creates, I believe, 1, 2, 3. It has 3 endpoints. They're all running localhost in the port 3000. And so you have these 3 endpoints, which is localhost 3000, port 3000 books, localhost 3000 add, and localhost 3000 delete. And books expects a GET request, which is why we're doing app.get in line 34. Add expects a post request, which is why we're doing app.post in line 41. And delete expects a delete method request in line 63. And all books does is that it just returns a list of your books. Post just or add just adds a book to the list, and delete just deletes that book from the list. And there's some middleware at the top, which is basically just something that runs in between the request being made and the request sort of being handled. That middleware runs. So that middleware is for validating quote authorization. In this case, I'm just checking whether or not the tokens that a token is sent and that the token equals super duper secret. So don't actually do this in real life. You're not supposed to hard code tokens in your code. And you're also not supposed to have a single token for the entire API, and it should definitely not be called super duper secret. But just for the sake of demonstration, this is how I'm doing it. And basically what that does is that every time you try and make a request to any of these endpoints, whether it's books, add, or delete, then it will check that token and whether or not that token is valid. And if it's not valid, then it will send either a token is required with a 401. I believe 401 is unauthorized. And if the token is available, but it's not the right token, then it will send the message invalid token with a status code of 403, which I believe is forbidden. And by the way, these don't need to be accurate. So technically, you can just send a status code of 200 for everything, although that's just not very useful for the client, and it makes whoever is working with your API's life just a little bit harder. So as much as possible, please stick to the correct status codes. I think it's just like sort of good manners whenever you're writing an API. And yeah, like I said before, books just gets your books. Add, in add as well as in delete, it also does a little bit extra validation. It's checking whether or not a title is sent. And that is essentially what a REST API looks like. So if you try and follow the instructions in the README, and sorry, I forgot to mention at the top, there's some other middleware that comes from Express. So the first one is just middleware to parse JSON. So without this, whenever you send JSON to this API, it will not be parsed correctly. So that's why we use that. And the second one is to enable cross-origin resource sharing. This is kind of, it might take a while to explain, but basically this allows your API to be used by websites that are not in the same origin or the same URL, basically, or the same host of your API. So I believe origin specifically means protocol, host, and port. So in this case, it's running an HTTP localhost port 3000. So without that, if your client app or your client website is not running on HTTP localhost 3000 as well, then your browser will just not let it make requests to this. It's like part of a security specification. And what this does without any additional configuration is it sets a particular header. I forgot what it's called. It's like access control allow origin or something like that. It basically sends that header to the browser, telling it which origins are okay and are allowed to sort of use this API. I don't know if this is a good explanation, of course, but yeah, that's what it does. And in this particular case, without any configuration, it allows any website to use this API, which might not be a good idea either. If you're actually building your own API, you might only want your own website to use it for various reasons. Okay, can you go back to the presentation, please? Yeah, and here is an example of using a REST API in your front end. So previously, we talked about interacting with the REST API, and as well as creating our own REST API. So in order to sort of put those two things together, we want to try and use a REST API in our own website. In this case, it's with JavaScript with React. So if you can go to the repository. Yeah, these are very simple setup instructions. You can just clone the repository, move into the directory, you can install dependencies, and then just start the app, and then everything should work. Can you go to source or src app.js, please? Thank you. Yeah, so this is basically just how you work with the API that we just made. So first, I'm just specifying your API URL at the top, as well as the super secret token, which once again, don't do it like that. Typically, when you have a token that you need to send to the API in your front end, you definitely don't want it to be hard-coded, because for one, it's just not a good idea to have it in your code, because you might be checking it into version control or like GitHub, and your repository might not be private, or you might not want to share it with other people that are working on your project. And also, if you hard code it like this, then anyone can basically see your token if they just sort of inspect your source code in their browser. It should not really be static at all. Sometimes it's okay to have it static for certain things. So in that case, you want to put it in an env file and then read it from the env file. And this env file will not be checked into GitHub or Git. This is probably something that you want to set in wherever you're deploying this website. So for example, AWS or GCP or Heroku or anywhere like that. Or usually in a front end, when you have this sort of super secret token, then it's usually sort of generated dynamically. As in, what I mean by that is that, maybe as a user, you log in, and if your login is successful, then the server returns some sort of super secret token, and then you can just keep it in a variable somewhere as part of your state. So it's kept in memory. It's not kept in the source code. Yeah, and this is just one big component called app. In Flutter, this would just be a widget called app. And at the top of app, we have various use states. So this is our state management. So if you're not familiar with React, what this basically does is that when you do use state in the first line, use state empty array, and then you have books, set books. What this basically does is it returns an empty array called books. So we've initialized it as an empty array, and set books. And set books is a function similar to set state in Flutter, except all it does is it sets the state for this particular variable, which is books. And then it's kind of the same thing for title, author, error message. It's the same concept, except those three are initialized with a empty string instead. And then we have a use effect. So what a use effect does is it's a React hook for side effects. So it's when you want to run things in certain parts of the component lifecycle. So in this case, we're only running a certain function when we first render the page. And this function is called fetch books. And fetch books is really just a function that wraps around the previous example of interacting with APIs. It's just doing a GET request to our API /books. As I discussed previously, that's what books expects, except this time it's sending a super secret token in the headers, specifically in the authorization header. And this is because, as I showed previously, we use that middleware to make sure that all of our requests are authorized. And after we've made this response, then hopefully we've received something back that's correct. And it's just a JSON object with a single key, which is books, which contains an array of books. And if this is successful, then we set the error message, we reset the error message if there was any, and we set our current list of books to that list of books. And we wrap this all in a try catch error in case anything wrong happened during all of this. And in case if that is the case, then we do set error message to error. And later I'll show you what this error message is used for. We have a couple other functions here called handle title and handle author. These are just very small wrappers around the set title and set author from the use states above. And this is just to handle the input values, which I'll show later again. Then we have handle submit, which whereas fetch books was for interacting with the books endpoint, here it's interacting with the add endpoint. So as we've seen previously in the Express server, the add endpoint expected a post request. So here we're specifying that the method is post, and we're specifying that, again, that in the headers that we're sending our super token. And we're also specifying that content type is application/JSON, because we are sending stringified JSON in our body. And yeah, in our body, we're taking an object which is just contains the title and the author, which comes from our inputs, our form inputs, which I'll show later. And we're stringifying it. We're basically just converting that JSON into a string, and we're sending it. So even though it's sent as a string, when it comes to our API server later, because we said that the content type is application/JSON, it will be parsed as JSON. And if you don't add this content type, I don't believe that the JSON parsing in Express will work correctly, which is kind of what you expect from any sort of API server. And here we're doing something that we didn't do previously. We are still wrapping this in a try catch block to catch any errors. However, we're also checking whether or not the response returned okay, which is just shorthand for the response returning a status code of 200. This is because certain implementations of these sort of fetching libraries, so in this case it's fetch, but in any sort of language, you probably have your own version of this. Every single one kind of implements the specification differently. So the fetch specification is that I believe it will not throw any error on any status code, even if the status code itself indicates an error. So the try catch here will only catch if, I don't know, something went horribly wrong. But even if the API server returned a 500 error, which, if you will remember, means an internal server error, it will still not be it will still not, nothing will throw, no error will throw here, I believe. And there's a whole bunch of other status codes which basically indicate something went wrong. And not all of them, or I think none of them, will be caught. So we need to check that explicitly here. So if the response is not okay, so it's anything else but a 200, then we set an error message so that we can show it later in the UI. We call fetch books to sort of refresh our list of books. And the next function is just handle delete, which is very, very similar, except instead of working on the add endpoint, it's working on the delete endpoint. And instead of a post request, this is a delete request, which is kind of very similar to a post request, except you're intending to delete something, deleting some resource in the server, in this case, a book. And it's very, very similar, except here we are not sending the author, we're sending the title instead, because in this particular API, the title is kind of the unique ID. Although in a real API, you would probably send something more unique, say like a unique book ID or something like that. Yeah, so those are basically all the functions that we're going to be using to interact with our API that we already have. And what's left is just the UI itself. And you don't even need to really run this to sort of understand what it's doing. It's because it's very short. So at the start, it's just showing the error message if it exists. So we're checking whether or not the error message variable contains anything. And if it does, then we're going to show the error message. And then we have just a header that says reading list. And we have a little form. And this form contains a title input and an author input and a button that says add a new book. And whenever you type in the title input, it calls handle title. So it saves our input values to the title variable. And whenever you type in the author input, it calls handle author. So it saves that value to the author variable. And then when you click add a new book, it calls handle submit, which if you'll remember is sending the title and the author to the /add endpoint in order to add a new book. So that's basically it. And in the bottom, it's basically checking if books is empty. So it's not, it might be a bit confusing, but that's basically what it means. If our books array is empty, or if the books array doesn't exist at all, really, then we print out no books found. Otherwise, we will take a look at the books array, and for each book, we will render out this list item, which contains just the title of the book by the author of the book. And then beside it, we have this button where if you click it, it will delete that particular book. And how it does that is that it calls handle delete, and it passes in the title of the book. And as we saw previously, handle delete just sends a delete request to the API. Again, with the content type application/JSON and the authorization token, quote token. And if you wanna sort of see what that looks like and have it work with the actual API, you can sort of run both at the same time. So they are meant to be used together. You can run both at the same time and just sort of click around the React app, and hopefully that should work fine. It's just very simple styling, so it's not really very important to have it run. What's more important is that you just sort of try the more interacting with REST API examples previously. Can you go back to the presentation, please? Right, and go to the things to think about. Right, so I've just shown you, we just browsed through some code of implementing authentication/authorization in an API. So the question is, how does this look in a real API? Previously, that wasn't sort of real authorization because everything was hard-coded and there was only a single token. So some things to think about is like, how does it look in a real API? I previously mentioned there are different authentication methods like cookies or JSON web tokens. What are the pros and cons of using these different ways of adding auth to your API? Because there are definitely like pros and cons, whether that be in sort of like developer experience, like how hard it is to implement, like how much more work is there to do to implement that sort of thing. And then there's sort of security implications. And this is a good place to start thinking about overall security in your API. Because besides usability, making sure that your API is available and that it works as intended, an important thing to think about is security, because your API could be dealing with very, because in an API, you're really just passing around data, and some of this data could be sensitive. So for example, it could be user data. So if you're trying to build a, I don't know, like a social network or something, then your API, some parts of your API will be returning private messages of your users, or maybe part like data about the user's profile that they might not want to share it with everybody. And if you don't think about the overall security of your API, then you run the risk of exposing some of these endpoints and having them accessible to people without who don't necessarily have the correct authentication or authorization, which is always a bad thing. And a good resource that I've linked here is the OWASP cheat sheet. So these are just a set of pretty good principles or things to think about when you're designing a REST API. And I do encourage you to go through the entire sort of, well, I mean, it's like a lot, but I mean, browse through the entire OWASP sort of websites or guides, because I found that they are pretty good guides to like the standards of web application security. Another good thing to think about is, what is a good way to structure your endpoints? Because previously we just saw 3 endpoints, and they just sort of came from like the root of, I mean, they just sort of popped off like the actual origin. So I just went localhost port 3000/add/books/get, which is fine. But when you're building a quote real API, you might have a lot of endpoints. you might have, when you sort of say you're thinking about expanding this reading list and you want to turn it to something more like Goodreads, then you want to have a lot of different endpoints, not just for retrieving your books, but you might want to have an endpoint for retrieving books for a specific user. And maybe you might want to retrieve books in a specific category, or you could have it all these as different endpoints, or have it all as one big endpoint and only change the behavior based on what you send in the body. It's really up to you, and like it's something that you do have to think about and research for yourself, because there's a lot of different ways to do this. And structuring your API is very important. Thinking about how to structure your API properly is very important, because you might not be the only one. Like the API that you're writing may not just be for you, but it might be for other people in your team, or it might be for hundreds or thousands of people that are using your API. So you want to make sure that your API is structured in a nice way. And a good place to start is the Stripe API documentation, because Stripe's API is very nicely structured, and also their documentation is pretty well written. And this is also a good place to practice reading API documentation, because previously, when we were using our own API, we were able to figure out which endpoints to use and how to use these endpoints, because we already have access to the code and we can just sort of read it. Plus, I've explained it, and there's nice comments there to help you understand it all. But then you look at the previous example with interacting with the REST API, where you're trying to get a list of books from a certain author. Well, how do we know how to do that? How do we know to use that particular endpoint, openlibrary.org/search.json, and like append this author parameter? How do we know how to do that? Well, we know how to do that because you just look at the Open Library API, and they have their documentation there, and then they tell you which endpoints are available and how you interact with these endpoints. And when you're working with any sort of public API or a private API where it's meant to be accessible, then they're typically going to have documentation to tell you how to interact with the API. And so it's a good thing to practice reading API documentation. Sometimes API documentation is not very good, or not as good as Stripe. So it's also good to sort of play around with different APIs and practice building your own, so you kind of get a sense of how things are usually done. So in the case that an API is not well documented, you're not exactly sure what kinds of things to send to the API, or maybe what you might expect the API to return. In those kinds of cases, you do kind of have to rely on your prior experiences, or just be comfortable with playing around with that particular undocumented or not well documented API in order to figure out what's going on. Another question: how does fetching from an API work in a real app? So yeah, previously it was all just one component, and it was just fetching all over the place. And the error handling was basically not error handling, it was just printing out the error message at the top for the user to see. And these are not great. So a couple of things to think about is, where in your code should you fetch? Previously, it was all in the same place. UI logic was basically in the same place as the fetching logic. So this might not be a good thing. When you have enough fetching and enough UI stuff going on in your app, this might be very confusing. So you might think about, how can I separate that? How can I better organize my code so that these don't happen in the same place, or these are sort of logically separated somehow? Or if they even need to be separated, that's up to you as well. That could be something where, if you think about it a little more in your app, you might want them to be very tightly coupled, and that's fine too, but it's a good thing to be thinking about. Also, reducing code duplication, because previously, as we saw, some of our requests were very, very similar. We're just sort of changing very, very small things. What's a good way to reduce this code duplication? Can we maybe extract that out, sort of a common function, and only have certain parameters that you add or tweak in order to change the kind of request that you're making? I don't know. It really depends on the app that you're making, the website that you're making, what kind of API that you're interacting with, and really what is right for you. But again, it is a good thing to think about, because it sort of forces you to practice thinking about these things, which will be very useful when you're working on a quote real app. Another thing to think about is better validation on the front end, or better handling of errors. So yeah, as I said previously, the errors were just handled by just printing out the error message, which may not be a good thing. You might want to do certain things on certain errors, or you might want to handle the errors better, so you can show maybe like a more helpful error message than what is returned by your API. You might also want better validation on the front end. So right now, I believe there was no validation on the front end. There's validation on the back end, or on the API server. So for example, if you didn't send a title, then it would not successfully, it would not return a successful response. But it didn't do any validation on the front end, which is also important, because when you're not doing any validation on the front end, then you end up with things like, so if you actually ran the app, then if you didn't enter anything in those inputs and you still pressed add a new book, then it would still send that request to the API. And you might not want to do this. You might want to sort of force the user, or whoever is using your website, to sort of enter the correct things first and then send it to the API. You shouldn't rely on front-end validation for things that are sensitive, or really anything. But it is a good practice, so that you can just have nicer validation, just tell your user, tell your user the right things to input without having to touch the backend. Another thing is debouncing your requests. So previously, it was possible to sort of just basically spam add a new book, and every time you clicked add a new book, it would send the request over and over again. It may be a good thing to what's called debounce your request, which is basically just kind of just throttle them. Just don't have some space between your requests, force some space between your requests. So an example of debouncing your requests, where maybe it'll be a little bit more clear, is when you have a search input. So if you have a search input and you're trying to search something, say in the YouTube website, if you're searching upon every key press or every change in the input, or I don't know, YouTube might do this because they can it's fine for them. But for a smaller website, or where you're running your API server yourself, it might be a lot of load on your API server. If every user, when they're searching something, every sort of key press is sending a request, it might be a lot of load on your API server, and multiplied by how many users you have. You might want to fix this by making it so that your website waits a certain amount of time after the user stops pressing things. So that way, instead of having tens of requests just with a very simple search query, you might only have one, which is when the user stops typing and you sort of wait a little bit and then you send the request. So that's another thing you might think about. Another thing is caching responses. I think the browser already does a little bit of caching by itself. But what I mean by caching responses here is sort of, when you make that request, so for example, like in the fetch books function, then you might want to save that, and you might not want to sort of run that all the time if nothing has changed. In this case, things did change, but yeah, I mean, you might want to think of places where you can reuse the information that you already have, and so you don't have to hit the API server over and over again to fetch the same information. So yeah, that's another thing you can think about, like where is that appropriate? Where is that not appropriate? Where do you want to cache things? Or where in places in your app are caching things just more trouble than they're worth, because sometimes they are. Sometimes you have to deal with stale data if you cache things. Sometimes you need to, you need to keep track of when you need to renew that cache or your stored data. So yeah, that's another thing to think about. And lastly, or not lastly rather, another thing to think about is fetching a lot of data a few times versus fetching as many as needed. So in the app I showed you, we kind of did both. So in the case of, so we sort of fetched books every single time anything we made, every single time we made a request, whether it's deleting something or adding something, we just fetched the entire list of books as well as in the initial render. This is not ideal because before we only had you might only have like a handful of books, but say the user has hundreds of books, then that might not be a good way to do things, because every single request might be over and over getting the same list of hundreds of books. So this might not be a good thing. And you might think of something like, if you go to an e-commerce app, is it better to fetch the entire marketplace at once, or only fetch whatever needs to show up on that given page? In that case, it's kind of obviously the latter, but there are many cases where it might be useful to fetch a lot of data just once or twice, instead of fetching things, small things over and over again. These are the kinds of things that have a lot of trade-offs depending on the kind of website that you're building or the kind of app that you're building. So it is something to think about. Okay, next. You now understand sort of the basics of working with APIs, hopefully. And if you don't, you can feel free to ask me as many questions as you'd like later. Can you now try and figure out how a certain website's API works? This can be up to you, like anything at all. If the API is public, then try and see if you can understand it from the documentation. So here I linked a pretty big list of public APIs. This is obviously not exhaustive. It's just happens to be whatever this repository has collected. But this is a pretty good list. And there are some pretty popular public APIs here that people usually use to learn how to work with APIs. Things like the IMDb API or the, I don't know, the Star Wars API, I think, called Swappy. Yeah, you can take a look at a couple of these, and they have their documentation there. And these are very easy to work with. Some of these need you to sign up so that you can send the API key, but some of them don't. So yeah, you can practice working with APIs here, because all the documentation is hopefully on the website. And the majority of these don't require you to sign up or anything. So it's a good place to practice interacting with API, or maybe using this data in a front end of your own, whether that be in an app or in a website. If the API is private or not intended for public use, then there's not much you can do, but you can still take a look at your browser's developer tools. So my particular shortcut is Control-Shift-I, but it might be different for different browsers or operating systems. You can basically, you don't really need documentation if you can just look at the network tab of your developer tools and go to any website and just load the website. And in the network tab, you should see, particularly in the xfetch/xhr category, then you'll basically see what the website is doing and what API it's using and what requests it's making to that particular API and what is in those requests and what did those requests return and what are the headers in the request and the response. And using this information, you can basically figure out what any website does with their API. And if you really want, you can try and use it. Although, if it's not intended for public use, then you should probably just not do that. But you can. I mean, you can do that with any API. And yeah, you can. That's basically how things like it. So if you go on GitHub, there's plenty of API clients for things like the Gojek API or the Grab API or the Tokopedia API. I don't believe any of these are public APIs. Like, they're not intended for public use, but what people have done is that they've, for example, in the Gojek API, they've basically intercepted API requests from their phone in order to figure out what the API is, what the endpoints are, how to use those endpoints, and basically that's why they've made those API clients. So yeah, you can basically figure out what any API is doing. Sometimes these are obfuscated. So sometimes the it's just not a very usefully named endpoint, and maybe the data that it's sending is just sort of single variables. Sometimes it is obfuscated, but these are a bit harder to figure out what they're doing, but hopefully you can still figure this out. And yeah, that is the end of it. Yeah, I had wanted to show you the apps directly, but for one reason or another, I'm unable to share my screen. So hopefully you can still run those on your own. And if you have any trouble running those, feel free to just chat in the type something in the Zoom chat, and or just message me directly somehow, and I can hopefully help you there. But that hopefully explains a little bit about the basics of working with APIs, whether that's just interacting with the REST API with like a script, or making a small REST API of your own, or using an existing REST API in your front end. Oh, and one thing I forgot to mention, which seems pretty important, is that this is basically how browsers work. Browsers are very complicated, and there's a lot of things going on there, but you can make a very simple browser by just making GET requests to things. So whenever you go to a website, it's basically making a GET request. It's doing other things, but it's basically making a GET request to that URL. And so if you run the Express API and you go to your browser and you type in localhost 3000/books, then it should hopefully show you the actual data in your web page. And that's because it's just making a GET request. Yeah. And in the additional resources, I've just kind of linked some things that I've already linked throughout the document. And that'll be it for me. Does anybody have any questions? I think that was pretty quick, but does anybody have any questions? Please feel free. It's all right if you didn't understand everything, because I went very quickly and I didn't get to demonstrate anything.
Okay, thank you, Kak Farel. So yeah, guys, do you have any questions? You may ask him directly. And let me check the slide though. Wait. Okay. Okay, there is one question here, so let me share screen the Slido. Okay. Yep. So I will read the question. In REST API, what if we want to update or refetch the data automatically, such as chat app where we don't know whether there's new data into the database, I guess. So can you help me with this one? Thank you.
Right. Well, there's a couple ways to do this, I think. If you want to update or refresh the data automatically, you might want to use WebSockets. It's kind of like a protocol where you can do something like this. Basically, just open like a socket to the server, and then I believe you can just listen for changes and certain events, and then what your server will do is that when there's like a new chat message or something, then it'll just post that event to the client, and then it'll just because it's listening for it, then that's when you know there's a new message or new data in the database. If you don't want to use WebSockets or anything like that, then maybe you can just do polling. I mean, it's not really automatically, but polling is basically a method where you just on a certain interval, you just sort of keep asking the server whether or not something has changed. So in this case, you might want to just poll the server every, I don't know, 10 seconds or something, and just ask for like a certain flag or something, like has something changed? And if it's true, then maybe you can ask for like something, a more complete response. That's one way you could do it. I don't know. There's probably more ways to do it, but off the top of my head, you could probably either use WebSockets, or if you don't want to do that, then you just poll for changes.
Okay, I think there's no other question. I have waited for some time right now, so I think I'm just gonna wrap the learning session here, right, guys? So yeah, thank you, Kavarel, for joining us today. The explanation were very clear, and you tap into the web development things which we don't cover much in this learning session. In software engineering patterns, we just literally going to, all in Flutter. So thank you very much. Some web development stuff here, and yeah, I guess that's all. And don't forget to fill in your attendance form, guys. Thank you.
Thank you.
Next learning session.
Bye.
Bye.